Well, this is interesting. You see how the crack in the wall, my jealous wall, that appeared after this collapsed. But yet they're stating that it collapsed. The collapse was because of the vibration from the next door. And yet this didn't even make it. This building collapsed. And the question that begs to differ is that since your building collapsed, with that strong amount of vibration during the collapse, did your building damage 87 Park? If so, can now 87 Park sue you for damages because your building possibly did damage to their structure? It's it's conversely, contrary. Your building now did this huge vibration, clearly probably exceeding what they've ever exceeded. So now cannot 87 turn around and sue in the neighboring properties, sue Champlain for causing this excessive vibration into the structure? Kind of an interesting thought. So plinth beam, I was talking to the structural engineer guy yesterday down from Florida, and let's look at an elevated plinth beam. That's all tie beams there. Importance of plinth beam is ideal height in residential building above level. Acts like a tie beam that keeps columns wall. That's going to be important, this tie beam thing, because let me show you what I'm driving at here. Let me show you what I'm driving at. Well, we know that the building comes over here like this, and then it's a different color. And then at one point it skips holidays, if you will. And this would be, let's go larger because just for the sport of it. So we'll go. And I'm going to do this on purpose. I'm going to change the color now. Grab another one, and I think I'll use this. Oh, okay, that works for me. I got to start drawing the drawing first. So this is what's important to me. And that's the color I'll change to. Let's change that to green. Yeah, green works. All right. So this is This is the BMAs, right, where the planters are. This would be K. This is L. And let's call this M. Okay. So the plinth beam is the highest one above the floor. That's that 1 foot 6 inches that was supposed to be 2 foot 6 inches. So that lateral bracing has now reduced down to 1 foot 6, the plinth beam, let's think of it as. It doesn't go directly across the building. It goes this way, stops at this location, comes out, and I believe it sits on, these two sit on top of this. So it looks, let's look at the profile of it. Let's do 1 and let's do 2. Oh, great, I can't rotate that. So let's do 1 and 2. Hopefully they square that up good. All right, girl, you're not going out. It's too cold out. So here's this one, and we're looking from the end view, from the garage, if you will. And then on top of that sets this other beam there. And let's change the color of that one. It sits on top of it like that. Oh, gosh. Yeah, she does that. That's why I told you when she got somebody snatched her up one day. I knew they wouldn't be able to keep her. If she was in the neighborhood, they would just put her out after that because they can't take it. That's her way. She tries to wear you down. I usually just tell her shut up right now, or I give her hugs and kisses, and then she's happy. Come here, let's try that one. Come here. And then I also try to seem like I'm trying to give her hugs, and she'll run. Hold on a second. Come here. All right, in this case, it didn't work. She's taking the hugs and kisses, so I got her on my lap, got her in my hand now, and just put her on my lap, and I'll pet her until she leaves. All right, so this one is this one, or you can invert it to this one, but right now it's this one, let's say. And you see the difference of them, that they're offset. So any pulling, say, of this one pulling on that one. So let's do a side a view like this. Yeah, that's going to work for us. That's going to create a rotation there. Oh, she's purring too. But that doesn't mean it's going to be a long purr. And now let's have that collapse. As it collapses, as it rotates down, it creates a torque on this one, which would cause this one to fail. But maybe it held on for a while before it went down to the ground, and that gives us our secondary collapse mechanism. Remember, over here we have planter boxes that present as level. We have planter boxes that present as level over here, but over here we don't have that. We have a video coming this direction of materials on the ground. So this is the one that went down individually. It had nothing backing it. See how it's on top of it? I don't think it was inside. I think it was on top. And let me think about that. Yeah, I think at this section, you climb it down? You can climb down. I'm not going to stop you. Nope. She didn't want to climb down. And so at this section, when this goes down, it did create some drama and trauma inside this cross member here between L9 and 11.1. Is that 9.1 or 9? And then 11.1. Anyway, this right here. This probably bought the 7 minutes before this finally buckled, continuous buckled, failed, rotated down, and then caused the rest of the collapse to progress with the extended spans, unsupported spans of the first floor, resolving itself right about here, dropping down. Now I got to work my way back into the building, because remember, when we see the video, about approximately 2 to 3 floors have already started going down together at the roof line. Remember, the roof line has at the roof, they only have 4 pieces of rebar in the columns. All right, so you got 4 pieces of rebar. I showed you this in the previous videos. And if you were to remove one of these, you now have, removing by it failing, by rattling, you're now trying to hold up the structure with 3 pieces of rebar, and the stress and strain. Remember, on 611 over here, above 111, she notices cracks in the wall. She takes her time to do all this stuff to leave. She does that. That means that at 611, the walls, the front C column, I believe, the C column, the C row there, it is now separated from the building to some degree. That's where her door won't close, and so we have some loss of engagement of the steel from the pad, and which also caused some deflection and etc. But it became stable again for those 7 minutes before it progressively collapsed. During those 7 minutes, Cassandra Bilodeau Stratton made a phone call to her husband. As he states, he's mentioned in his video that I've yet to finish. I stopped it at that point because it was so profound what he was saying. Is it how she was stating she saw water filling up in the garage, or water in the garage, something to that effect, from her view. Now, I do have a lot of views from her balcony from there, but I don't know. You know, I have to worry about the sensitivity of the family, so I don't want to trigger those things. But they did a view showing the view from there. But Cassandra has images that literally from the balcony, I can see her viewpoint down. And yes, that's about where she would see what they showed. Would she be able to see down on the first level with the balconies in the way, to see the first level, the porch area up here gone? I do not think so. She'd be limited probably out to here, where she would see, and over below her, of course, where she'd be able to see that. Underneath the parking garage, probably not in view at all. She would have seen what she thought, with her knowledge, as a sinkhole, because you're in Florida, you know about sinkholes, and that would be that. I mean, you would think that, and you wouldn't possibly not panic because it looks stable in your mind. You know, so the husband may be beating himself up, but, you know, of course, he wouldn't have, in hindsight, the husband would have said, leave. And everyone may be saying, you know, he should have not talked on her phone that long. Well, I would have done what the husband's done also. Maybe talk to her, calm her down, tell me what you're seeing. Maybe send me some photograph. Send me a photograph of it. Let me look at it. And that would have been terrible. I would have felt responsible, and so how do you get rid of that guilt? That's a tough one. The husband, it may look calm, cool, and collective, but, maybe he can't present himself as distressed because of his career path, and he must remain calm, cool, and collective. But I can't imagine that he's not, ripping himself up on a quite frequent basis. And I know some other personal things about their relationship, but I don't think it's relative, especially at this point, because, they both loved each other. All right, so we don't pick who we love, right? I mean, we do, but that's the way it is. So, he's obviously traumatized, and I wish he would, somehow fight more. But we can't. Everybody fights in their own way. Everyone fights in their own way. Some people use lawsuits to fight and get to it, and we find them to be going after money. That may not be just true. I mean, you're going to have to go after the money. Yes, you're going to have to make them punished financially. But what would be more is something that says something like a Cassandra Stanton law, where now you've got to notify all tenants no matter what. Once they're a tenant, they still get notification. Even if she was going to buy a unit there and may have had one previously, or maybe not, but you're still a tenant, so you're still entitled to know the hazards at that point. Different unit. You can't assume that because one person got a disclosure on a property that's the same disclosure for every property. So no, that all those renters that were there, that they're the true innocent people without the disclosure saying, hey, this building, needs all these repairs and it's structurally, unsound. Here's a copy of it if you so wish. I think tenants need to be notified of that when you're renting, of all the condos. Yes, it may be troublesome. So what? But they need to make like a Cassandra Stratton law, and I think her husband is powerful enough to make that, Cassandra Ability Stratton, to make this happen, where everyone will get notification if you're going to rent inside a unit. That would then calm down and also force the owners of these units to do the repairs. It's kind of a catch-22 with it. It kind of catches everything. Because now if you notify people like look at it and they're like, well, I'm not renting there. And make it so that they have to underline red ink all of the hazards. So if they can't just bedazzle you with a huge report, that they're not also allowed to do the narrative unless they did the narrative in a meeting. So they have to release their meetings to the potential renter, and as it relates to this. So if it's really meetings go back 3-4 years, they have to release the minutes to all of them, holding back no data, redacting no data. So they have a right to make they should have a right to make a fair judgment on whether they want to rent there or not. So that's my thinking there. Now let's do this, and then I'm gonna get back to what I call the Cassandra Ability Stratton law. They like to name it after victims, and that's you can call it I like that one. I always name it after one victim, not a bunch of them. So this pulls when this goes down. This butterfly effect pulls on this area over here. It could be just a matter of rotating this one out, which will leave these three intact. Remember, the floor is still a floor, but it's elevated up here. It looks something like this. It's an elevated floor as it comes back down to the. Let's do this now before I say elevated. That would be out here and here also. They each are to come up at 12'9". I think their elevation is, and this deck is 11'10". So it's those many inches off the deck. They create this plinth beam. Oh, she's doing good. She's sleeping right next to me on the papers. They love papers. So as this goes down, this some way or another loses its interaction here. So now it can't keep this side and that side stable because these are needed to keep them stable. The deck area is probably not needed to keep this all stable. This up here would be nice to keep it stable, and the deck area here to keep it stable. I'm going to shorten that a little bit. Oh. So to keep... That didn't quite work. All right, so if you remove this one, you no longer have this continuation. Now let's get back to the video I wanted to get to. Let's move this off to the side. And let's see what this guy says about plinth beam. He's got it on the ground, a grade beam. They're just about the same. Their intent. Let's see. Yes, you got to get used to the accent.
There are various types of beam in structure that we studied.
You can read this.
But when anybody asks a question in interview like, what is some confusion in our minds?
Yeah, you can read the closed caption.
To remove that confusion, stay tuned with this video up to the end. And it's really appreciable if you like this video and subscribe my channel. Let's learn something.
And you guys come to this channel.
It is
for looking at the difference between plinth and beam and tie beam.
Necessary to understand the important terms which will help you further. First and very important term is plinth level. It is the level where the substructure ends and the superstructure starts. In simple words, it is the topmost level of the ground level. Second important term is plinth beam. The beam which is provided at the plinth level is called a plinth beam. In frame structure, plinth beam is the first beam constructed after the foundation.
It's the first beam constructed after the foundation. Plinth beam is the first beam constructed after the foundation. We have no grade beams in this structure. So our plinth beam becomes the 1'6", which was 2'6". All right, that is the plinth beam now. And the intentions of what it does down there is the same intentions it does up where we are on the first floor. My opinion.
The purpose of providing the plinth beam is to distribute the load of walls over the foundation of building, to connect all the columns.
Remember, if you lose one of them, we now lose we gain in that torsion, that rotation that can happen. And all we have to do is lose these, and now we've got two separate buildings wanting to react differently because we got a floor now, a slab, internal slab that's not supported the way it was intended to be supported, or the way it was built to be supported with the 1'6" elevation change. Of course here, this floor level in here, keep this in mind. This is 1'6" over here, from the deck to here, 1'6". But from here, we're at 12'9". 12'9" to 1'6". We have even a smaller plinth beam dimension. This is 1'6" over here, but over here, our internal floor is still at 13'4", inches, I believe. 13'4", and we're at 12'9". And then we still at the bottom, and we have a clearance here, so it's some clearance of the cars coming down. So they reduced it even more. So this span here, right here where the cars are much more reduced. So we got 13, let me do my math, 13'4" minus 8 inches. So it's about, let's see, 12'9" and 8 inches. Yeah, it's about 9 inches. It's about 9 inches over here of a plinth beam butting up against the 1'6", etc. So you can imagine that once this goes, this is vicariously on top of the columns there, that other part of the wall. But it's being, it's sharing that column. So, and that's only but it's a 16 by 16 column. It's a C column.
To prevent cracks from the foundation to...
Hold on. You move that away. As Dr. Patel says, to prevent cracks from foundation to the wall.
The wall and to avoid differential settlement. And the third important term is tie beam. The beam which is connect two or more columns or rafters in a roof or a roof truss or in any height above floor level is called the tie beam. Tie beams are mainly provided in the roof truss and at a plinth level. This
And at the plinth level. You understand that? They can be at the plinth level, and they can be, of course, tie beams in the rafters and a roof system. Yeah, he does a really good video there. So so this is our tie beam, but it's not consistent. It's a jog here. It's a jog here, and the lateral loads could not be resolved or taken by the failure of the deck. IMO.
These beams do not convey any floor loads and only
They do not convey any floor loads. So the slab design in each one of these floors, it's two-way. It says it's a two-way slab system, is what the Morbido report states. Two directionals. So they're stating that the 1'6" is not a beam acting as a beam capacity for that two-way thing. Nowhere in his report did he state that the front of the building, that the 1'6" elevation is acting as a beam capacity. He does not state that we saw, that I saw anywhere. So these beams do not convey any floor loads and act as a length break for columns.
act as length breaker for columns where the floor height is unusually very high. The purpose of
So length breaker is length breaker. So length breaker, so your slenderness factor. So let's say let's do 2 floors, right? We're just going to tie these in, and then we'll put a floor here. All right, so that's its length breaker to make it rigid. Let's put another one here. That's that one, right? So now if I remove this, let's say now this height is now 20 feet. I remove this, there's 20 feet. I put it in. Now it gives it rigidity, strength, and now it breaks it into, it's interacted in rebar. And now it gives it some framework, some rigidity, and now it's reduced it to 10 feet and 10 feet. Pulling away, we got 20 feet. Now the loads can now buckle and cause failure, especially if we remove this. If it's a rebar in there and this collapses, it's going to pull out some concrete, and that's going to reduce its compression capacity. All right, so we have the decks here, and let's go right over top of this. We have the deck here, and we have a column. We have another column here. And this is KLM, let's call it. Up here, and when this one goes away, well, this out here is only, the parking garage one is only still the same height, the 1310. That's already designed to be freestanding, and it's turned, and actually this is turned, I believe, this way. So that's already freestanding, needs to turn more square. So that's already freestanding, so there is no lateral bracing for it. It's designed to stand strong like a tree, right? Like a post. It can do that. Inside the building here, these are designed because of the sizing of C. This is not oversized, even though it's by itself over here on the corner, and then the cars come through, and then this will be a corner one. They did not make these larger. They kept them as C's, even though they have a driveway. This one has a driveway through it. They didn't make it stronger, more rigid to act as that way. They said, you know what, this will pick it up. This will pick it up over here, and this will pick it up over here to make this stronger. As you can see, that's on a little bit of an angle. So if this goes down, it could rotate that column or tear out some reinforcement, which would make this weaker. More so, the slab. Once we get this weaker, the slab, the spans are what matters, and how much this falls down and tears at the supporting column here, right about here on M, and that's what matters there, or tearing out, ripping apart. And let's move over here.
Of providing the tie beam is to carry axial compression, to transfer the rafters load to the column, and to prevent columns from the buckling.
Okay, from the buckling.
Now coming to
the buckling, to prevent them from buckling is what he's referencing is this. This keeps it from buckling. If I move it away, I got a higher height. Put it back here and there. We're talking about the slenderness factor, and as the other guy said, the ratio.
difference between plinth beam and the tie beam, which is the original question. Actually, there is no difference between them. Tie beam is also a type of a plinth beam. When tie beam is provided at plinth level, it is known as a plinth beam. That means the only difference is the height at which they are provided.
Yeah.
Plinth beam is only provided at plinth level, but tie beam is provided anywhere above the plinth level and the floor level.
Okay, you got that? So tie beams can be at anywhere above it or below it, but the plinth level is the plinth level.
So it is all about the difference between plinth beam and the tie beam. Let's wait for another video on new topic and fresh knowledge. Till then, good.
Let's go here again. Let's hear.
Structure starts. In simple words, it is the topmost level of the ground level.
In simple words, it is the topmost level of ground level, above the ground level.
Second important, simple words, it is the topmost level of the ground level.
And we have that would be this flooring here. Hey, look, guys, I gotta go. That was my page there. I've been waiting for that, so let me make sure. Let me see if I have to go. And backing up. And yep, I gotta go. Okay. Gotta go, and I'll post this, and I have more to it. And so I want to put out an olive branch to, because we need to get the data out there. And since I'm being shadow banned, we need to get. I need to mark it with somebody now. All right, so plinth beam. I want you to think about that, about how important it is that the plinth, the interaction of what a plinth beam does. Research it. And I'm also doing this for an engineer that asked me, because he didn't know what a plinth beam was, to ask me about it. So hopefully he'll now understand a plinth beam and how that 1'6" and how this reduction over here because of the offset and the reduced size of this. So 13.4 to 12.9. Oh, it's not 13.4. 11.10. 11.10 to 12.9. All right, I did that mistake already. I remember that. You guys said, no, you're messing up your math, and I remember that. That was not funny, but 11.10 to 11 inches. So this plinth beam, if you will, is now 11 inches. Either that, or they said this will be plinth, and this would be nothing here, and then this would be plinth. So that doesn't make sense because they didn't do anything to resolve that rigidity here that would be needed. The lateral movement, and of course we see lateral movement in this failure. All right, so this is our plinth beam smoking gun video. Hopefully you'll understand it. Hopefully I don't have to go over it again. But please watch the video again and follow it. Take care.